This is Giancoli, problem 1821. And this is about resistivity. It asks us what's the resistance of this block. It says that it's made of carbon. And part A asks what's the resistance for current going in the x direction. Let me label these axes really quickly. This is x, this is y, and this is the z direction down this way. Alright, so it's a three-dimensional block, a parallelepiped if you want to get technical, and we've got the x direction for part A. Now if you remember the formula for resistivity, I'll write it here because we'll use it for all of them, for resistance, is the resistivity times the length divided by the area. Alright, so each direction you flow current through this block of carbon, you'll have a different resistance because you'll have a different length you're going through it and a different area that you can pass the current through. The resistivity in each case will be the same. The chart in the book is less than helpful on this. It gives a wide range for the resistivity of carbon, but at the end of the problem you can see that it tells us rho is equal to 3 times 10 to the minus 15 ohm meters. That's the units of resistivity. Because we're going to multiply by a length, that would give you meters squared, and then divide by a meter squared, and you want resistance, so it needs to be ohms times meters. Part A says, what is the resistivity in the x direction, or the resistance, in the x direction. So resistance is the resistivity times L. In this case, L is A, right? That's the length for part A. And then the area is B times C. It's the height times the width. So it's B times C. All right, let's plug in some numbers. 3 times 10 to the minus 15 ohm meters. Need to multiply by the length, which is 1 centimeter. That's 1 times 10 to the minus 2 meters. And then divide by B and C. Okay, so B from the problem is 2 centimeters. 2 times 10 to the minus 2 meters. And C is 4 times 10 to the minus 2 meters. So this meter can cancel with this meter, and this one with this one. This 10 to minus 2 can cancel with that 10 to minus 2. And we've got the resistance is equal to, oh dear, sorry about that. This resistivity is only 10 to minus 5. Okay, I fixed the values of the resistivity. They're 10 to minus 5. I'm sorry about that. So we've got 3 divided by 2 times 4 is 8. So 3/8 times 10 to the, you got minus 5, divide by 10 to minus 2. That's like adding 2 to minus 5. So it's minus 3 ohms is the only thing that didn't cancel. For part B, it asks what the resistance is in the y direction if you run current in this direction. And so in that case, your length is B and your area is A times C. See, it's this area right here, which is A times C. Okay, you can plug in the numbers and get the answer there. And then for part C, it says what's the resistance in the Z direction. Maybe I should have labeled those R, X, Y, and Z. It's rho. It's flowing in this direction now. And so the length that it travels is C, and the area is B times A. All right, plug in the numbers, and that's the end of that problem.